Okay, yeah, I'm gonna kind of like redo the last half of this video because Flatcam started freaking out on me or something. I guess because of the recording equipment, I don't know, but I'm just gonna like redo that whole part. Okay, let me. Ugh, fuck! Fucking god damn it! No, open. Okay, open this one again. I didn't save anything, so it should be blank. Okay, bottom layer, top layer, our holes layer, and our edge cuts layer. Opening that up. I'm really pissed that this is still acting freaky. Change the colors. The front layer, so it's going to be reddish. Bottom layer is going to be light blue of some kind. Okay, they're both there. Alright, bring in the Exelon object. Okay, there's the holes. Okay, instead of doing it the way I was trying to show you using the double-sided tool, I'm not going to use that the way I was trying to use it before. Instead, I'm going to actually just use it the way I would to mirror the layers. I'm going to do it the way I would normally do it for a single-sided board because that works almost flawlessly. Let's see, so the bottom layer I need to mirror, and also my holes layer I need to mirror. Everything else stays where it is, including the drills. These are the only two layers I need to mirror. The bottom layer and the layer of little mounting holes are on. Because those all get done in the first operation. I don't need to mirror the edge cuts because technically it's symmetrical. Because my board is rectangular, and because of that I don't need to mirror it or anything like I would have. Like I'd need to if it was some kind of weird, shape. So non-symmetrical shape. So let's go to options, and you see you got this flip on x-axis and flip on y-axis, right? So it's the hotkey for it is Y and X. So you can use the menu or the hotkey. Now I'm going to use the Y. Normally I'll use the X, when I'm doing just a single-sided layer, and what that'll do is that'll flip it from left to right. In other words, just like this, but it still flips it within the bounds of this box. It's just a lot simpler than using that double-sided tool, which is a little convoluted. So, but here I want to flip it up and down, and you'll see because I'm going to put our reference points like here and here, where we actually flip the board, with our little thumbtacks. So since I'm putting it here and here, I gotta flip it along this axis instead of, if I had our little reference holes on the left side and the right side, I would flip it along the x-axis so that the board has to flip this way. Instead of top to bottom, it would be left to right, but we're doing it top to bottom here. So I'm going to go ahead and flip that along the Y layers. Alright, and see that keeps it bounded right in the box. So it works out perfectly. There's no confusing bullshit like this double-sided tool tries to do. But now I'm going to go and do the double-sided tool, Okay, so I got to pull up the two-sided PCB so that we can put our little reference holes in. Now, like I said before, notice down here you'll see the X and Y coordinates. See? I'm going to hold my coordinate there and make note of the coordinate. X is 1.17 inch. So, and here's our origin over here, right? Okay, but from that origin, our X is 1.17 and our Y is 1.25. Now, when I designed the board, it just so happens that this area is free down here, but also on the top, there's really nothing there either, so it's clear. So I know I can put my reference holes there and have it, mirror itself along that axis. So in order to do that, again, notice the X and Y coordinates, 150 mil up and 1,175 mil over, or 1.175 inch over. Push and hold the control button and left click your mouse. That actually copies that coordinate, and then you put add here on this alignment drill coordinates, right? Okay, notice the value it pasted in there. That's where our first hole's going to be. Now, be sure to set this to box, okay, and I think this X and Y means the same thing here, and better. I'm going to be pissed off if it doesn't, because I'll have to redo it. And like I said before, the hole doesn't need to be that big, because really I'm only going to make it 42 mil, but just so it shows up, I'll go ahead and either leave it here. Fuck, I'll just leave it like it is. It doesn't bother me. So let me make sure it's using the right reference drawing. Now, this is not the drawing. It's using my fucking holes drawing again. You want to use the edge cuts as your reference object for the box properties. Alright, now let's create the see, it did it wrong. So this Y does not correspond to what this Y means. So because this Y, if you go and let me go and show you what I'm talking about. Let me go and hide the top layer here. See what it did? It flipped our board from bottom to top, which is what we want. But this, it didn't flip the same fucking way. So that's what I'm saying. That's why this gets so fucking confusing, because these people are so inconsistent. They don't sit there and think about how confusing this is going to be to somebody. But hey, they're just doing it for the fun of it, right? It's freeware. So, fuck you people. That's their attitude. But anyway, let me enable this plot and go and delete this. Either this, or you can just hit the delete key, which is usually faster. And let's go back to our double-sided tool, but instead of, since this has a different definition for the y-axis here, because this is actually proper, it's actually flipping it along the y-axis, which is how you would think. But the other tool actually works the opposite of what you might think, depending on your background. At any rate, let's go ahead and flip it to X, because that's the right way to do it. And now, voila, it's in the right fucking place. Okay, groovy. Alright, so we got our reference tools, and the layers are flipped. And again, if you go mess with this, it gets just as confusing. Don't ever use this, as my advice, even though it does work. But again, it's a lot more straightforward just to use this. Because, the part of the video I deleted, was about me having trouble flipping with this, and then eventually everything just going crazy. So just do it the way I showed you. You'll have a lot better of a hair day. You want a bad hair day, do it this way. Want a good hair day, do it the way I showed you. Okay, but that's got these things flipped and everything. Now, let's go ahead and see, it already created the Epsilon drill object, and what that means is that we have this little thing here. Alright, so this is about ready to do a cut. Now, since we're using a drill bit, I'm going to keep this at 100 mil depth, because I like to make sure I over plunge through the board. Even though it's only a 62, 64 mil thick board, you know, I would still like going 100 mil anyway. Travel's fine, etc. Let's generate the G code for it, and Bob's your uncle. Okay, so let's go in and save the CNC code for that. And yes, I want to replace it because that's from the previous attempt. Should go delete those damn files. This is a CNC code. It's real short. So again, the G code for this is actually really short. It's just a couple of holes you're drilling and everything. And you can kind of look at this as a reference if you want to learn G code because it's simple. You know, there's not a whole hell of a lot of coordinates, but this, you know, helps starting with something simple if you're curious about learning G code, because it does come in handy sometimes. But at any rate, okay, that's got that done, and I'm really done with the double-sided tool at this point. But I'll just ignore it since there's no good way to close it. And let's go do the edge cuts now. Now, like I said, I could use this tool to do it, but it actually, because this is actually what you use to like route traces, and that's how it's set up. That's why it has like a 4 mil depth and just all this other crap. But instead, I'm going to use the cutout tool. Like I don't know if I'm going to leave this part of the video in, because I probably will before, where I talk about the you know, the gap you can perform in the tabs. But like I said, that part I'll probably leave. Because I haven't edited the video, the original video yet, but I am going to go ahead and cut it. I am going to go ahead and do it in fucking Corel Video Studio, or Movie Studio, or whatnot. Just to edit that nonsense out. Okay, but I'm set that to none, and like I say, I'm going to make this, like, instead of 62 mil, which is my actual bit width, you know, that's the actual size of the router bit I'm going to use. Let me go ahead and pull that stupid movie thing up again, because I got so mad I closed it. I don't know if I had that on. Hold on. There we go. Okay. So yeah, instead of, you know, that's the actual bit I'm going to use, which is like a 1/16 of an inch bit, 62 mil or so. But I want to, as I said before, I want to trick this thing so that it overroutes it because of those, you know, the coordinate, you know, generating the, you know, the height map and candle here. It just it gives me a little bit of an extra buffer. So I'm going to tell it I'm using a bigger bit than I actually am. So I'll set that to that. And again, I got the depth to 80 mil. I got multi-depth at 20 mil per pass. So it'll do like 4 passes essentially at 20 mil deeper every pass. But I'll hit the generate rectangular geometry. So since this is just a simple rectangle, and of course that did it wrong because this program's so stupid, it won't do the logical thing. You just got to get used to the fact that you know, that you got to pay attention to what layer it's using in these various tools. It doesn't recognize this by default as an edge cut, so it, you know, keeps going to my user drawing for some stupid reason. So make sure that's set to edge cut, and again, none, and again, what a pain in the ass. 100 mil, that's 80 mil depth. Okay, now generate rectangular geometry. Voila. Okay. Now, like I said, my tool, if I chose 62 mil, this line, instead of being here, would be a little closer to the board, like here. But by putting it here and only using a 62 mil bit, that makes my board a little oversized, so it'll help me in case there's extra, it gives me a little buffer in case there's extra error, you know, when I go to do the leveling, you know, height map on that second, on the front side of the board, after we flipped it over. So anyway, but that's got that taken care of. So let me go back to this. And again, make sure you check your multi-depth and all that stuff. Make sure I'm on the right thing here. Say edge cuts. So generate the CNC job. Alright, so basically, you know, that's where it's putting our tool, but it thinks our tool is 100 mil, but it's only actually 60 mil. So anyway, that'll just make sure it'll give us a little, you know, like a 38 mil, you know, extra buffer around the edge of it. Again, in the future I may not do it this way, but for now I'm just being cautious. That's why I'm doing it this way. Let's go save our code and overwrite that motherfucker. And alright, so that's got us going. Now the next one we want to do is we want to go to our user hole, and we're gonna, you know, again, these are our mounting holes on it. But you noticed, you know, that even though, and you can see right here, these circles here, these are actually on the edge cuts layer, but it ignores them, you know, when you're using that cutout tool. And if you're not using the cutout tool, it'll really generate fucked up results. Which I could show you that, you know, if you wanted to, but you can find out for yourself if you try to put mounting holes on your edge cuts layer. You'll see what happens. Basically, it'll do things in kind of a crazy way. It just won't work the way you're wanting it to. There's no good way to tell it to do that I've found so far. So by having a separate layer with your actual, you know, with your actual, well, actually, this is the cutouts hole. This is our drawing layer hole. At any rate, by doing it this way, it just makes things a lot simpler, because you're going to want to do this as a separate pass anyway, even though you don't have to. Traditionally, I don't on other machines, but on this is how I have to do it. But at any rate, okay, we're wanting to go, you know, to a circular tool, and here we're going to tell it 62 mil, which is the actual diameter of our router bit. You know, because I don't need to worry about it being, I mean, I want it to, its size to be exact. You know, this is a hole, it's not our edge route thing. Shit. I didn't even think about this, but yeah, this is going to end up being a problem when we get around to it. I wonder if I should do this differently. Yeah, because I was planning on, basically, I was planning on doing this, yeah, because I just thought about this, you know, because when I do, if, you know, I was planning on, you know, because I actually route the edge cuts first, you know, you have to, you know, because on your, you know, on your, you know, on your tool, the first thing you do on your board is you know, you route your little, your two reference holes is what we're going to do, the ones that are at the top and the bottom, right? And then you go route your board out. You know, you got to level it first. You got to generate your height map, okay, in Candle. And after you do that, then you drill your two reference holes, you know, at the top and the bottom of this thing. You know, the ones we just generated in the two-sided PCB tool, and then, you know, you go and put your router bit in there and route out the, you know, route out the layers, you know, the like the bottom layer, which you've mirrored, right? But after that, you know, I was going to go ahead and cut the hole, since we'll have the router bit in it anyway, and then you edge route the board, right? And then after you do that, you'll be able to flip the board over, okay? But the problem is, if I drill those holes first, well, when I flip the board over, then my height probe, when I do the height map for the top layer, it'll run into those holes. So really, I should just, even though I have to change the tool out again, I should actually route those mounting holes on the other layer instead. So let me go ahead and, again, I've not done, you know, many double-sided boards with these CNC tools, so it's a learning experience. But yeah, since I'll have to do this again for the other side, I don't want this probe running into those mounting holes, and yeah, because you can go edit these values if you want to, and just kind of figure out an approximate value yourself. But it's better just not have anything it's going to run into. that's why I don't drill the holes first. I actually drill the actual holes on the top side, you know, once I flip the board instead of on the bottom side. So, yeah, it seems to work okay. It did on that last board I did. But anyway, I got to go get rid of these. Hope this doesn't freak out on me again. But yeah, this since I haven't routed anything yet, let me go and select, you know, our user drawing layer. Okay. God damn it. Fucking god damn it. Piece of shit. Okay. And then let's, you know, flip it on the y-axis so it realigns. Now, at this point, it should be realigned with these original holes, I think. Yeah, it should be realigned with the original holes. So now we can go cut this out. So now it's going to be on the top layer. So this will be one of the last operations we do then, instead of one of the first. You can see the last board I did, you know, I had mounting holes in it. Damn it. You know, I had mounting holes in it, you know, in the corners, but I was able to do those first because they didn't interfere with the copper. So they were outside of my height map grid, so it wasn't a problem. But here, since I decided to put the holes on in the middle of the board so that I didn't have to make the board too wide, so I could, you know, use as little of this copper clad as possible, you know, I decided to put the mounting holes on the inside, which is fine. But so I've not tried this way, but yeah, the technique I used last time won't work. So that's why I'm going to have to go ahead and do this way instead, and just make it a top layer thing instead of a bottom layer thing. Okay, so we got this. Hole diameters, right. And we don't have to mess with anything else other than this, so let me, oh, wait, damn it, I fucked up. You know, this program, you've got to like be really aware of what's going on, because it's easy to fuck things up. Now maybe when I've done a lot more boards I might be a lot more experienced, but I'm making this video just as much for me as you in many ways, although it wouldn't be this long if it was for me only. But I don't make any money out of this or not, or anything, but I'm just making it this way so that I've realized that I got a video at least I can watch and see all the gotchas if I want to sit there for like 6 hours or however long this damn thing will be. Okay, let me go back and do this, and again, don't use full. You use that when you're just doing regular trace routes, but we need to do an internal route, because what it did before is it actually generated both a you know, circle on the inside and a circle on the outside, and we don't want that. So let me go ahead and generate that, which doesn't seem to have done anything. Son of a bitch. Here we go again. Okay, it's the right layer. You know, to use it on follow mode. If you use it on follow mode, it'll actually follow the actual trace. So, you know, like if I want it to actually follow the outline of the holes right in the middle, you use follow. That's what that does. It comes in useful if you're trying to do like silk screens or something. So, you know, you had like text, so, you know, instead of it routing on the outside of the text, you'd want it just like a T, you'd want it just, you know, do the one route that way and one route that way, rather than have it go around the edge of the T. So that's why that's what that's for. So what the fuck is this thing doing wrong? Sure as fuck isn't generating any geometry as far as I can tell. See, this is what it started doing before. You know, it'd start just misbehaving like this. It's not doing anything. Oh, wait a minute. No, it is doing something. It's just Yeah, the holes are on the wrong fucking side. God damn it. Okay, I guess I flipped it wrong or something. I don't know what. Let me... God damn it. I'm gonna go just fucking delete this motherfucker. Okay. I guess it's gone. Now let me bring it back in. This is what I was getting into before. I'm going to get pissed off if it starts acting crazy again. Okay, so I know this is in the right orientation. This is how I want it because I don't want this mirrored at all, this layer. Alright, so let me go and do 62 mil here. Okay, and internal, generate geometry. Alright, so there we go, we did it right. Those are our paths and the holes, that's where they're supposed to be. Make sure something else didn't get fucked up here real quick. Okay, yeah, that looks right. Okay, alright. So now we've done that. Now let's get our Z set. Now again, this is going to go all through the board, but it's a router bit we're using, so I'm just going to go 80 mil depth. Okay, that's fine. These things are fine. Generate CNC object job. Okay, so as you can see, it kept that to the inside of the hole that I wanted to route, not the outside or somewhere else funny. Okay. Alright, so we generated that. Let me go ahead and save the code to it. Alright. Alright, so that's got those completed. Now, so that gives us our edge routes and our little mounting holes. Okay, so at this point we can go and let's route the bottom layer, and as such let me hide the top layer just so you can see what's going on. And it's good to keep an eye on this because this gets a little tricky. We don't need to see the drill holes because the drill holes, remember, we didn't mirror, but I'll still leave them up there. They might bug you a little bit, but you know, you can see these are really frickin' narrow. This is like less than 5 mil, so that's why I'm going to use like a 30-degree V-tip bit on this, you know, just so you can get these real narrow passages. And I'm going to do a multi-pass on this too. On the top layer, it's not as, I don't have, I really don't have a lot of traces going between pads, or between IC pads like you see here, so it's not going to be as difficult to do as this. The clearances don't have to be this close. I think they're like 20 mil, but this is like less than 5 or less mils. So let's go to generate this object. That's the right layer. Let's choose chart. So even though I'm using a V-score bit, it's better just to do it the way I'm doing it because you just kind of get a feel for it. And I can tell you with the 30 mil bit, I should be able to go to a depth of about 6 mil or so pretty safely. But this thing just, it'll give you a hell of a time. It's just better to treat it as a circular bit instead of a V-shaped bit. Just because it's just the results just work better. It's okay if it overroutes a little bit. And that's why I'm doing it this way, because you're going to have a hell of a time actually making it route this trace. It'll be over routed the way I'm going to do it, just a little bit, but not too terribly much. But I don't want to have to go do all the frickin' symbol libraries and everything else over in KiCad in order to make this fit right. So that's why I'm doing it this way, is just to make sure that I have independent manual control over it. And that's why I'm going to use a circular bit instead of the V-shaped bit, because if you can see, you know, the tool diameter is based on the depth here. So if I set this to 30 mil depth, okay, so I'm going to use a 30-degree V-tip angle. You know, its tip is supposedly 4 mil tip, right? That's what the specifications of the tool said. But your cut Z determines what this kerf is, you know, the tool diameter. That's your cutting angle. If I went to like 8 mil, okay, see how it increases that? But if I go to like 2 mil, okay, you know, it changes that again. But the thing is, 2 mil, you're barely going to cut through the copper, and I don't know that height map is going to be that accurate, so I wouldn't even begin to try it at that level. Not right now. Now it may turn out that you can do it that way, and you probably can if you want to fuss with it a lot, but the way I'm going to do it will work and not be nearly as big of a headache. Let's see, so a tool diameter, I'm going to tell it, you know, it's 0.048 mils what I had to do to get it to work before, and I am going to do more than one pass, so but I'm going to show you what it does with just one pass first, and I'm going to change this overlap as well in this event. You want this set to full, okay, and the scope all, etc. You know, and combine, you want to have that set, because by default this program doesn't set that. You got to set it up in the options. So let's generate the geometry, and this is why I say I wish this program had a preview mode, so you didn't have to keep going through this and deleting these things over and over and over again until you get it right. But see how some of these traces, you know, it barely made it. And right here, this right here tells you, you know, you got a full line going through it, even though there's a stupid hole there. Ignore that. That's not applicable. But you know, these two lines merge. That's as wide as I can make that route. That 4.8 mils. That's as wide as I can get it. If I made it any wider than that, I'll show you that. It's 4.8 mil. So let's just take it to 5 mil. Again, I wish this had a fucking preview mode in it, so I didn't have to keep doing this. Let's see. Let me try to find an area. Well, let me go ahead and hide those stupid holes. Okay, so why isn't it fucking hiding the stupid holes? Okay, you done? Alright. Okay, see, this is what happens when you even make it 5 mil. So that 0.2 mil difference, you know, means this isn't going to be fully routed. This trace does not go clear through like it's supposed to. So, you know, whereas this one does. At any rate, let me go ahead and, you know, delete this. And delete this. Okay. And then let's go back to our copper layer and switch it back to 0.048 mil. You know, and even though this particular situation may not apply to you, you could still run into this. So I'm showing you techniques to deal with it that I've learned. But like I said, you know, we had that single pass at that and it worked fine. But I want to do a second pass. Now, so what I'm going to do is I'm going to set the number of passes to 2, just to try to make sure it clears things out a little better, because again, with such close spaces, man, the propensity for solder bridges to occur between like this pad and this trace are really high. So I'm trying to, you know, and this won't really affect this, but it will affect these other areas, because even between these two areas, yeah, you don't want a solder pad forming under a chip or something that you can't get to. I mean, a solder bridge forming under a chip or something you can't get to. But anyway, I'm going to go ahead and lower this to like 10%, even though you can do like 15%, and you know, 15% might be better. But this is where combine comes in handy, because if I didn't set combine, it'll actually make each pass a separate object. But let me go ahead and show you what happens. Okay, so we got, you know, two passes. This is the first pass, you know, like right here, but then the second pass, you know, comes right over here. Okay, so, but you can see the second pass won't go through here, but that's why you need to make sure the first pass is skinny enough. But this percent overlap that I chose, or that I was messing with, you know, that is how much overlap, that if you can think of this as a round tool, okay, this is how much one circle would overlap with the other circle. Okay, and let me, you know, show you more graphically here by finishing this off. Okay, so I got this set to 4 mil, but I'm going to go ahead and set it to 6 because we're using a narrower angle bit. You know, again, I usually use 45-degree angle, but I'm going to use 30 on this one. You know, 45-degree is sturdier. That's why it's nice to use a wider angle instead of a narrow angle. The chances of breaking a bit are lower. So the tip off your bit are lower. We don't need multi-depth here because we're only going 6 mil deep. You know, it's 6/1000th of an inch. Anyway, let me go ahead and generate the job, and you'll see what this is going to come out to. Okay. Again, I wish I had a preview mode. Now see, this actually, because it thinks the bit's only like 4.8 mil, I'm surprised it did this actually. Oh no, it did right. You can see here's the center of this trace, here's the center of this other trace, and then on the other side, since we have a copper fill, it's tracing around that too. Okay, so this is what it thinks is going to happen. In truth, our cut depth width is actually going to be bigger than 4.8 mil. It's probably going to end up at, you know, like 5.5, 6 mil, but that's okay if it overcuts a little bit. That's why I use 25 mil traces here, so you can, you know, stand to lose a little off the edges if your bit's over route, and that will happen if your board was like a slightly different depth than the machine thought it was or whatever. You know, you'll see that, you know, it'll get narrower or deeper because you're using a V-shaped bit. Now, if you went and used the, you know, the cylindrical mill bits, which they do have those, they're a little harder to find, but you can find them on Amazon. They're hard to search for though. But they're really delicate, but they are just straight up end mills, so you don't have to worry about it being, you know, wider at one depth, like at 2 mils, than it is at 8 mils. It'll be the same width no matter what, because it's a cylinder instead of a triangle, a V shape. But at any rate, you know, this will actually come out to where it actually removes all this material. You know, you may think it's not going to, but it will. And you can add a third pass if you want, or fourth pass, or whatever. You can add as many passes as you want, you know, when you're doing this. So, you know, I mean, you can do it to where you route literally all the like all this area. You know, you can do it to where you actually clear this off completely if you wanted to do enough passes, but that's a lot of wear and tear on your machine and your bits and everything else, so I suggest keep it minimum. But you know, but this does help too, right? You know, sometimes when you're routing more than one bit, because it also helps clean the traces, because, you know, you get little copper flecks sometimes in some of these routes, you know, like in a single route. And a second, you know, a total second route will actually remove that stuff, as will if you just did a single trace and then just ran it again. It'll help clear those things out, but it does take twice as long and everything. So so it's just up to you, but this makes it at least a little more solder bridge resistant, you know, by doing 2 passes, and given just how narrow and how close these tolerances are, that's why I'm doing a double pass. On the other side, I'm not going to do a double. I'm just going to do a single pass instead of a double. But at any rate, so that gets us this right here, right? So, you know, we've already generated the CNC job, so let's save the file. Okay. So Bob's your uncle. Okay, so that's got it really for the bottom layer. You know, the first set of machining we do before we flip the board over, it'll involve, you know, us doing those two reference holes at the top and the bottom. Okay, and then we'll route out the traces and then we'll route out the edges, and that'll allow us to flip the board over. Okay, so that's got that stage of it done. So let me go ahead and turn off some of this stuff to get it out of our way. Disable that, and this and this, just to hide it. Okay, then let me re-enable the front layer. Alright. Okay. So, here's our front trace. Now we're going to do something similar in it, but as you can see, I don't have as narrow, you know, we just don't have the same kind of, you know, close tolerances and tracks and everything that we had on the other side. So on this side, I'll go ahead and switch to circular, and I'll basically, because I may actually use a 45 mil bit on this side, you know, 45 mil router, or 45 degree router. But I'm going to estimate its size to be, you know, again, the wider the bigger, you know, because what I really want to do is I want to try to maximize the size of the pads. So what I want to try to find is a trace routing width that's enough to where our bit will, as close as possible, you know, like go between these, you know, like between this pad and this fill. I'd like it as much in the middle as possible for both of them, because remember, it'll pass first around this, and then second it'll do around this. Okay, so you'll have two routes through it, but as close to each other as possible is where I'd like the path to be, because that'll make it so that I keep these pads as wide as possible. The wider the better when you're soldering these damn things. So, especially when you've got no solder mask, I mean, the wider the better. You know, it's what I always try to do. That last one, we didn't have any choice. I made it as wide as I could. But here, I'm going to try 16 mil at first. Again, I wish this motherfucker had a preview mode. Right layer, you know, full route. Okay, so I'm going to generate the isolation geometry, and let's see what it does. Okay, yeah. Okay, so these are still quite a ways away from each other. I could leave it there. That's actually okay. Because again, the actual width my bit will come out to remains to be seen. But usually it'll be probably like 8 to 10 mil, something like that, with a 45 degree bit. For the depth I'm going to use, which is usually 5 mil. So, and again, you know, sometimes I'll use 4 mil, but what I've found is that you get intermittent results sometimes. So I like to put 5 in there just in case, because you can always kind of reset your axis and do it all over again, and we may end up having to do that here. I wouldn't be surprised, but you know, when you're doing it in candle, you can always lower your, let me close this damn thing, but you can always lower your Z a little bit. It's a little bit of a pain in the ass, but you can do it, you know, make it like 1 mil deeper or something like that, and then rerun the whole trace again. So, you know, if it didn't fully remove the copper out of it, fully route the copper out, you can do that. So you just try to set it with a reasonable depth here is what I try to do. And you know, and again, this isn't bad. I may go ahead and stick with this because I know it'll work. So, and it's at least 16 mil wide, so I like that. So that still puts the tool itself very near the middle, even though the tool's probably going to be that wide. Again, it'll probably be more like 10 mil instead of 16 mil in diameter. It's probably what its actual cut kerf will be. So, let's see. So it's got our travel Z, our Z depth. Okay, let's generate the CNC job for this turkey and see what it does. Okay. Alright. So again, you know, that'll be roughly what we end up with. So let me go save the CNC code. Okay. Alright. So now that we got that motherfucker done, let's go ahead and light up our drill holes. Okay. Now, so as not to confuse you, let's see. What the fuck is going on here? Okay, yeah, that's fine. Yeah, because let me bring the damn stupid board thing up again. So I can show you what's going on. Alright, you see, that corresponds to this. This is in a fill. That's why it looks a little, may look a little funny to you. Damn it. Close this motherfucker. Okay, but you can see how this corresponds to it. But these holes are in fact right, even though it looks like they're not aligned completely. But in fact, they are. You know, look at the schematic and see what's going on it. See, so they don't show up as separate pads. Because I didn't put any strain reliefs in it, because there's no reason to, given what we're doing with these boards. So you just don't need strain reliefs on this stuff. They have them in there. The reason they have those strain reliefs that you sometimes see, and this program can generate them in a copper fill, is because when you're wave soldering a board, if you happen to be wave soldering it, by having those thermal reliefs on it, that helps each pad be approximately the same temperature when it's going through the solder wave, so it deposits a similar amount of solder on each pad. Otherwise, you know, on a pad like this, if you're putting it through a wave soldering machine, which I used to own a couple of them, if you put it through a wave soldering machine, what will happen is that these pads will be colder because there's so much copper around it, you know, and you got solder mask here, keep that in mind. So you get so much copper covered by solder mask, these pads don't get as hot, so either they'll actually glob up too much solder, because basically the pads don't get as hot as these pads do. So these pads may have the right amount of solder on it, but these pads here, because they don't get as hot, more solder will freeze to it as it comes out of the wave. So you'll end up with too much solder on some of these pads. That's why you really have those thermal reliefs. Otherwise, thermal reliefs are a bad idea, because if your if your component is generating a lot of heat, like an LED, for example, you know, if you're running at a pretty high power, and power is relative, keep that in mind. You're better off with a pad like this, so that it can dissipate its heat better, because most, like a T1 3/4 LED dissipates most of its heat into the circuit board. So if you have these thermal reliefs on it, that actually constrains how much heat, you know, can actually escape from the LED itself, because you want the heat to spread out as much as possible into the copper core. So that's why you want to avoid thermal reliefs unless you absolutely need them, you know, is what I'm saying. It's better for your component to help dissipate heat while it's running. You know, and that includes ICs like this too. They all have their power limits. Everything does, and the more efficiently they get rid of heat, the better. But if you're wave soldering, you know, you got to make a compromise for good solder joints, and that's why it's often done. So, but you don't need the thermal relief options like, you know, this thing has. So you got corner smoothing, pad connection, so you got solid versus thermal reliefs versus a relief for plated through hole, etc. So you can generate those, and it's kind of cool, but that's a lot more CNC work, and you don't need it because you're not wave soldering it. You're pretty dumb if you actually wave solder a fucking, you know, CNC board like this. You're going to end up with a fucking nightmare like you won't believe. Even if you HASL it and everything, it's just going to be a fucking nightmare. You know, don't do it. You're just hand soldering these in all probability. Anyway, the fact of the matter is, though, is that, you know, you don't need thermal reliefs, but that's why these pins may look a little orphaned, but they're not. They're where they need to be. Okay, but let's go ahead and do our Exelon routing. Now, I do something, and I may not do this forever, but I find it helps in case your drill bits walk. I'll do a pass. You know, you can see the cut Z is by default. I set it to 100 mil, which is where I like to keep it. But I will actually go through with my V-score bit, and I will do what I call a peck pass. Okay, so I make, you know, the depth about like 7 or 8 mil. You know, let's just put it at 7 mil. Okay, and I'll actually put a V-score router bit in it and just have it, you know, go in and just drill a little, you know, peck a little 7 mil hole in it. so that it's like taking a, like when you're going to drill a hole in a piece of steel, you take a steel punch and hit it with a hammer so that your drill bit doesn't walk. It's the same principle here. Remember, these drill bits are really small. They are delicate and they can take some walking, but still it's not a bad policy, especially if you aren't drilling your holes first. Drilling these holes is the very last thing we're going to do, which normally you don't do that in circuit board manufacturing. Normally, a circuit board manufacturer will drill all the holes first. That's the very first thing they do. They will literally stack drill their fucking holes all at first. Then they'll put their etch resist layer on it, which is a photosensitive material. They'll run that through, and semi-cure it, with a mask on it. Then they'll, remove the material. They'll the excess, the stuff they don't want, that they want to etch. They'll remove the material that's covering that, and then they'll etch it, and then they'll strip that off, and then they'll basically go in and put solder mask. Well, actually, I left out a step. They will drill the holes, then they'll electroplate them. That's the very second step they do, is they plate the through holes. Okay, then they go and apply the etch resist, the photo etch resist, and then strip the copper with etchant, and then they'll go in and put solder mask on it, and they actually make the solder mask layer so it actually fills the holes. It kind of covers the holes so they won't be etched. Well, that's actually incorrect. They do that on the on the etch resist layer. They'll actually cover the holes. When they're applying the solder mask, they apply that with the pads removed, and again, that's another photosensitive process. And then then they do like a hot air solder leveling, or they'll do a tin lead plate they call it. So that's the normal process they use. But again, drilling holes is first, and I normally do that myself because you can actually punch pads off the bottom if your bits are dull. So if you have everything pre-routed like we're going to do, and your bits are dull, well, does tend to be a little space that builds up under the board while you're drilling it from debris getting stuck under there, and your bit can literally delaminate the pad off the bottom of the board. So if you have like one of these little pads, these actually aren't held on very well, so it's actually pretty easy for a dull bit to actually punch that thing off, and I ran at that a lot in the early days. So again, usually on things like this, I try to drill holes first whenever I can. But if you're doing this as an amateur, if you're wanting to etch boards, you wouldn't want to do that, because you'll end up etching your holes out, and it's just a big pain in the ass. You kind of have to do it drill bit last instead of drill bit first. But anyway, we're doing a drill bit last, and but that's one of the other reasons I like doing this PEC pass, because it helps center the bit, so it makes sure it'll be right in the middle where you think it's going to be, and you're using something really solid like your B-score router to do it, so it'll be very precisely placed. And then when you come in with your drill bit afterwards, it'll go right into that little nipple that it, dimple that it made. Okay, so it'll be very precisely guided instead of potentially walking. If it the duller your bit, the more it'll walk. So it's something I don't think you have to do, but I'm just doing it to be safe until I get a better feel for this machine. Because this is a really low speed spindle, so like I said before, it's not going as fast as it should. So it makes me a little nervous, so I think it's worth taking some precautions like this. And plus, at these low spindle speeds, it'll probably be easier on your drill bit too, because you're actually putting a dimple in your top layer, where you want your hole to be, so that's at least some copper it doesn't have to drill through. So but at any rate, so let's save this down, but we want to rename this because it's not a drill pass, so I always name this PEC at the end. Okay, so now let's come back to our drill file again, but now we're going to go ahead and just because see, normally for this video, just not to confuse you, I started with the PEC drilling. Normally I start with the drilling since it's already by default set to that same depth, but I'm going to go ahead and set that back to 100 mil depth, and then go ahead and do it over again. And so this is our actual drill file right here that we're going to actually use real drill bits with. So save the CNC, and Bob's your uncle. Okay, now that's pretty much, you know, if you look at the project, you know, so we generated all these CNC drill jobs, save them all, okay, and you know, Gerber objects tend to lead to geometry objects. Epsilon objects lead directly to CNC jobs. So, so basically all these are associated with these later here. These, you'll find these only down here, the file that generates. But that's pretty much all the files we need, because that covers our mounting holes, that covers the top and the bottom layer, it covers our pecking routine, and our drill holes, and our edge cuts, and of course our mounting holes. So, but that's basically a complete set of files. Given how long this video is being, I'm really strongly considering doing what's next, you know, on a separate video, and that's actually bringing shit into candle and everything. So I'm going to think about it. And since I'm going to stitch this together, I'll still go ahead and do it as a separate video, just in case I change my mind later. Otherwise, I may just leave this as part of this big file. It's probably like 4 hours long if I do that, but you know, I don't know yet. So anyway,